In part B of the problem, we're going to calculate the average number of moves, tk, required to end the game starting at node k for k equals xy. And we're going to take the same approach we did in part A by just looking at the immediate moves from each node. So let's start with tx. So from tx, we can move back, we can stay on x with a probability of 0.5. And I'm going to add 1 here. And that's because if we move back to node x, the average length of our game will be the future average length of our game from tx plus the move we just took. So we just took one move to move back to x. So that's where that 1 comes from. Now we can also move to y with a probability of 0.3. And same idea, we're going to add 1 because we just took one move to y, and now we're going to add that to our future average length from ty. We can also go to w with a probability of 0.2. And if we go to w, right away, the length of our game is going to be 1 because we're going to end the game if we land in w. So that, in that case, we just have a 1 here. Now we can also do ty in the same way. So we can stay at ty, so we stay on node y with a probability of 0.4, and we're going to add the 1 again. We can move to tx with a probability of 0.2, and we're going to add the 1. We can go to w with a probability of 0.2, and that's going to be a 1 because the game ends. And we can go to L with a probability of 0.2, and again, that's going to be a 1 because the game ends. So this is an important difference from part A, because part A we were looking at the probability of winning. So that means PL, the probability of winning, is 0, whereas in this case we're looking at the average length of the game. And the game can end by either landing on W or L. And if you go directly from X to W or from Y to W or L, that's just one move and the game is ended. So that's why we have a 1 here for both TW and TL. I'm just going to take this equation here and just simplify it a bit. So I'm expanding the brackets. And then I'm just collecting like terms. That's our first equation. Now I'm going to do the same thing with ty. So I'm going to expand the brackets again. And collect like terms. So now if you notice, just like in part A, we have two equations with two unknowns, which in this case are tx and ty. So you would want to isolate one of these unknowns in one of the equations and sub it into the second equation. And you can use that to solve for tx and ty. So if you do that, you end up with tx is equal to 15 over 4, and ty is equal to 35 over 12. And this tells us the average number of moves, or the average length of game, starting at node x and node y.